Okay, so today we're looking at a deal that on the surface might seem a little niche, but it actually pulls together these huge industrial sectors.
Yeah,
We're talking heavy shipbuilding meets global cable manufacturing.
that's right. And they're converging on what is, probably the single most critical asset in the global economy today, the subsea information highway.
Exactly. So our deep dive today is on the joint venture between Prysmian and Fincantieri to acquire a company called Xtera.
And this isn't just a simple acquisition.
Yeah.
If you're tracking how physical infrastructure is meshing with the digital world, this deal is, it's a blueprint for the future.
So our mission is to really unpack the strategy here. It's a $65 million deal, which isn't huge, but we need to figure out what Xtera actually brings to the table, why this is so critical for the AI and data center boom, and what it means for the entire global supply chain.
Let's jump right in with the deal, because the numbers themselves tell a really interesting story.
Okay, so lay it out for us.
Prysmian is leading the joint venture. They're taking an 80% stake. Fincantieri, the shipbuilder, is taking the remaining 20%. And the enterprise value they've put on Xtera is about $65 million.
$65 million, okay.
But here's where it gets really compelling. The target company, Xtera, they're a leader in what's called turnkey submarine telecom systems. But they are incredibly lean. They're pulling in around 130 million euros in annual revenue.
Whoa, okay. Double the acquisition price in revenue.
Exactly. And they do it with only about 60 employees.
Yeah.
60.
Oh.
Spread across the UK and the US.
Wait, hold on. 130 million in revenue with just 60 people. That revenue per employee is just astronomical.
Yeah.
So why would a company like that sell for just 65 million? That seems cheap.
That is the absolute core question. And the answer is they are not buying factories or a huge workforce. Prysmian already has all of that. They're buying a very concentrated, very high-value portfolio of intellectual property.
And the 60 people who know how to use it.
Precisely. They are buying the digital brain of the network, not the physical backbone.
Right. And the deal is with HIG Capital, and it should close pending approvals sometime in early 2026. But the reasons behind it are happening right now.
Oh, absolutely. You have to understand the context. These submarine fiber optic cables, they're not just important, they are everything. They carry 99% of all intercontinental traffic.
That's a staggering number.
It underpins something like $10 trillion in daily financial transactions. But the growth we're seeing now, it's all being fueled by the hyperscalers, by data center expansion, and especially by AI. It's just demanding a level of capacity that older cables can't handle.
And this is where the physics gets really interesting, because it's not just about the optics anymore, right? It's not just about how much light you can cram down a fiber.
No, that's not the problem. Coherent technology has pushed the optical limits so far.
Where
The amount of data we can get into a single fiber pair is incredible. The real wall they're hitting is electrical. The power. You have this incredibly complex system, miles under the ocean.
Yeah.
All those little repeaters and amplifiers, they need electricity to run.
Yeah.
And there's a physical limit to how much power you can safely send down a cable over thousands of miles.
I love that. It's like you have this brilliant, super powerful light bulb, but the wiring in your house can only handle a tiny nightlight. You have the potential, but the system is just starved of power.
That is the perfect analogy. And that constraint has forced a complete shift in design philosophy. We've moved away from trying to maximize capacity on each fiber pair and moved toward maximizing the total capacity of the entire cable.
So this is where we get high fiber count cables, or HFC.
Right, also known as spatial division multiplexing, or SDM. The idea is clever. If I can't turn up the power on one line, I'll just add more lines.
So you run more fiber pairs in a single cable, maybe 16 or more, each at a slightly lower capacity, say 16 to 20 terabits per second.
Exactly. But when you add it all up, you get these massive systems, like 320 terabits per second on a transatlantic route, all while staying within that original power budget.
And this is the critical link back to the deal, because these new complex HFC systems are much, much harder to manage and monitor. And that's where Xtera comes in.
It's why Prysmian needs them. Because even though Xtera is one of only 5 companies in the world that can deliver these systems, they were still a very small fish.
How small?
Well, if you look at the market for what's called the wet plant, so that's the repeaters, the branching units, basically everything except the cable itself, it's dominated by 4 giants: ASN, NEC, Subcom, and HMN. Between 2015 and 2019, they had almost 98% of the market.
Wow. And Xtera?
Xtera had about 1%.
But that 1% was clearly very valuable.
It was their specialized proprietary IP, for solving these new HFC monitoring problems. And we know they defend it. Back in 2017, they actually went after Nokia and NEC legally, alleging they infringed on their patents for SLTE and other key components.
Let's define SLTE for everyone.
Sure. SLTE is the submarine line terminal equipment. It's basically the brain of the whole system that sits on shore. It handles power, it handles the optical signals, all the network management. The fact that Xtera had IP on both the wet plant and the shore equipment shows you how deep their system knowledge goes.
Okay, so the $65 million is all about their supervisory steams, the technology that monitors and controls all that equipment deep underwater. Can you walk us through how that tech evolved?
Absolutely. So historically, monitoring was slow. You had passive methods like loopback or coherent OTDR.
Coherent optical time domain reflectometry?
Correct, COTDR. It sends a pulse of light down the fiber and analyzes the reflection to find faults. But the problem with these passive schemes is they can take minutes, sometimes hours, to get a reading. It's like, you know there's a problem somewhere in the circuit, but you don't know exactly where.
So if the old way is like checking the voltage on the whole circuit, Xtera's tech must be more like pinging a specific device on a network.
That's a perfect way to put it. Their core value is what's called the active command response scheme. Instead of just waiting for light to bounce back, they send a digital request with a specific address for a repeater.
And the unit underwater responds immediately.
Instantly. It sends back a digital packet. You can scan hundreds of these amplifier pairs in just a few minutes. But here's where it gets really interesting. That packet contains internal diagnostic data.
Like what?
We're talking pump, current health, internal temperature, and get this, acceleration data.
Acceleration? From a repeater that's just sitting on the seabed, why would it need an accelerometer? Is it going somewhere?
That's the amazing part. It was originally put in there for sea trials, just to make sure the unit was deployed safely without being damaged. But customers found it was incredibly useful after deployment.
How so?
If a fishing trawler snags the cable, or there's some kind of deep sea event, that accelerometer can register the movement. It gives you real-time data on a physical disturbance that you'd never see with standard optical monitoring.
That immediately connects to the whole security angle that's driving this market.
It does. But the most important part of the active command response scheme is the control it gives you. It allows you to remotely reconfigure power and traffic routing in those complex branching units.
So you're sitting on shore and you can actually change the architecture of the submerged system on the fly.
Yes. And this is vital for modern open systems. In an open system, you might have different companies owning different fiber pairs in the same cable.
Right.
So if one operator wants to upgrade their gear, you need to be able to adjust the power going to their fiber pair independently without affecting anyone else. Xtera's active control is what makes that possible.
Okay. It's all clicking into place. The $65 million isn't for a factory. It's for the digital brain that makes this new generation of complex, high-security HFC infrastructure actually work.
It's a technology capture, pure and simple.
So let's shift to the investor context then. What's the strategic rationale here for Prysmian and Fincantieri?
For Prysmian, it's a total transformation. They are already the world leader in subsea energy cables, for offshore wind farms and things like that. They make the best cable. But this acquisition lets them move up the value chain.
They're no longer just selling the pipe.
Exactly. They get to sell the entire turnkey system, and they capture that much higher margin systems integration layer. For Fincantieri, it reinforces their big strategic pivot.
Which is?
They see the entire underwater domain as a key pillar for future growth. Their focus in this JV is very specifically on unmanned and security solutions.
And this isn't a new relationship. They already work together.
Right. Fincantieri's subsidiary, Vard, is building Prysmian's newest cable-laying vessel right now, a $250 million ship. So they know they can execute these huge, complex projects together.
Which all feeds into their main value proposition, the one-stop shop.
That's the pitch. You get Prysmian's cable and their world-class installation fleet. You get Xtera's system design and this proprietary monitoring tech, and you get Fincantieri's security, overlay guard vessels, drones, whatever you need.
It's a powerful combination, especially with all the geopolitical risk around these cables now.
Wow.
Being able to physically protect them is a huge differentiator.
It's become a non-negotiable requirement.
But isn't there a massive integration risk here? I mean, you're trying to merge three completely different cultures. You've got heavy shipbuilding, specialized manufacturing, and then this small, lean software and engineering group. Is that one-stop shop actually feasible?
That's the main risk, for sure. But the reward, if they get it right, is enormous. They can go to a hyperscaler or a government and say, look, we handle everything. Design, manufacturing, installation, the proprietary real-time monitoring, and the security package, all under one roof, based in Europe and the US.
They're selling resilience.
They're selling resilience, and that commands a premium. The argument is that the complexity of these new systems, plus the geopolitical risk, means customers will pay more for a single provider who can guarantee the whole thing works securely.
Okay, that makes a lot of sense. So we've covered the deal, the tech, the strategy. That means it's time for our high conviction segment. This is not financial advice.
Right. And our mission here is to find the alpha in this security and resilience mega trend. So Prysmian and Fincantieri are consolidating the top of the pyramid, the installation, and the systems integration.
The big picture stuff.
Right. But their entire promise of security relies on their component suppliers. Specialized, ultra-reliable components.
So we're looking for the picks and shovels play.
That's it, exactly. So the outrageous but plausible pitch today is a high-conviction, long-term, long position in a hypothetical, smaller, pure-play company, one that specializes in high-precision, deep-sea sensor arrays.
So the things that are actually measuring pressure, temperature, and critically acceleration. The components that feed the data into Xtera's active command response system.
You've got it. Imagine a company that used to just sell to niche defense or scientific markets. Suddenly, their super reliable sensor tech is indispensable for the multi-billion-dollar commercial telecom market.
The rationale is pretty compelling. The new Prysmian-Fincantieri giant has to buy this expertise from someone to deliver on their security promise.
It's non-negotiable. With AI demanding perfect uptime from these HFC systems, you have to have advanced physical monitoring. So this small, high-margin component supplier either becomes a huge contract grower or, more likely, an M&A target itself.
It's a bet on the absolute necessity of physical security in an age of total data dominance.
It is. So the ultimate takeaway here is that this $65 million deal isn't about buying a factory. It's about acquiring the proprietary control systems you need to manage and secure the most critical infrastructure we are building today.
And the key insight for you, the listener, is that the explosive growth of AI capacity translates directly into demand for these high fiber count systems. But even more importantly, for the ability to actively monitor and control them. Owning that whole value chain is the new barrier to entry.
So as a final thought, if this is the start of a trend, consider which other adjacent industries might be looking to do the same thing. Think about aerospace defense contractors or even large-scale civil engineering firms. Who else is poised to make a strategic move into this increasingly vital and potentially militarized underwater digital domain?
The battle for the seabed is really just getting started.
It is.
Fascinating stuff. Thanks for tuning into this deep dive. And just a reminder, everything we've discussed today is for informational purposes only and is not financial advice. Please do your own research before making any decisions. We'll catch you next time.